Hello and welcome back to another episode of the Oxford MAT Livestream. It's a live stream on YouTube brought to you by the University of Oxford where we talk about mathematics admissions test questions. And I knocked my microphone just after unmuting it, so sorry if you got a loud and sudden noise there. Good to see you, as much as, I can't see you, but I can run a poll, can't I? Let's try that. Let's see if anyone's out there on Slido. If you'd like to join in live, you can join in live over at slido.com/matlive, which is also where you go for polls. And we're going to do some more voting again to choose which questions we're looking at. Maybe starting with this How's Your Day poll. Off they go. Somebody in chat says that they've had the Senior Maths Challenge today. They've got TMUA on Monday. They've got MAT coming up. MAT Livestream now, here we are, here we're going. I'm always looking up for people who are having a terrible day. We will be alright, I think. Hello to Anonymous in chat, and Anonymous in chat, and Anonymous in chat, and Jacob in chat. You can be Anonymous in chat if you like. I'm not saying that you have to, Jacob, but you have choices. Isn't it nice to have options in life? Right, okay, people are having a terrible day. And one person says the terrible day will come on Monday, which I hope is a reference to something in particular and not a sort of ominous foretelling of doom, but I don't think it can be as bad as you're making it sound. You're making it sound pretty bad. Someone says penultimate, using showing that they were no word for one before last, because yeah, we're going to do another one of these next week. And there's a couple of bonus episodes coming up as well. In the schedule on the MAT Live page, you'll notice that there's one a couple of weeks after MAT to talk about the MAT a little bit. We'll look at the long questions. And then there's one a couple of weeks after that to look at some interview questions. So those are our bonus episodes, wrapping up the year of MAT Live streaming. There you go. People are having a real mixed bag up there, I would say, of possibly just today, or looking at the future, or looking at the past, or who knows. Anonymous says, should I do a TMUA paper instead of watching this live stream? I don't think I can tell you, right? I think it's up to you. I'm going to do the stream either way. There you go. I'm not going to replace the stream with a TMUA paper. Right, good. It's long questions for the one after that. That's what we did last year, it's what we're doing this year. Okay, star poll is not going super well there. They are on a 3.4 star day, which is maybe the worst we've had in the voting, so I'm just going to stop that there. I'm going to call that there, and I'm going to ask chat to choose what we're... I'm going to ask chat to choose what we're up to. Shall I do a poll for this? I think I will do a poll for this. Let's do a multiple choice poll, which past paper, and I suppose the options are, because of the video title, 2019, 2020, and 2021. I guess those are the options. Can you vote for multiple options? You can vote for multiple options, there you go. Start interaction. Hey! Oh, I do like a Slido poll, if that wasn't obvious. Anonymous says, don't say anything too important I might miss. I do try, but here we are. Kate had the SAT in chat. Seems like time of year for people to be doing things. Do I have any general advice, says Lily? Last few weeks here before maths admissions test. I think it's maybe getting to the point where you might want to do something else. I'm going to keep doing past papers. I've got about 6 of them left for my live stream this week and the one next week. But maybe if you've got ahead of me, then it might be a good idea to do something different. If you haven't done a times test yet, you could do a times practice test over the next couple of weeks. But you might have got to the point where you've got fed up with MAT questions and you want to look at something different. So I'm actually quite glad to hear that people have got these other challenges going on, like SAT or TMUA or SMC, because I think stretching those mathematical muscles by trying other challenges is probably good for you. My recommendation is not that you should do all of the MAT questions again or something crazy like that, right? I think you grow more by looking at other challenges. You can also tell each other in chat if you like how you found the SMC. Somebody in chat says, sad face, don't think I qualified for BMO. I suppose my experience of BMO is that it's another maths test. And if you do really well at that one, then your reward is that they give you another one. So in some sense, there's a lot of maths tests that you can do through, these are UKMT things that we're talking about in chat. Behind this poll, where it's a dead heat between 2019 and 2021, so I'm going to go left or right, I think. Interesting that chat's got an opinion there, so we will see. Right, stop the interaction. What types of questions do you hate? Maybe that's for everyone, not for me. I don't hate any of the questions. Okay, so 2019, sort of on screen. Let's do one multiple choice question very quickly. So we're just going to vote for like, are the votes going well? Well, we'll do the votes anyway. We'll do a vote very quickly in case it's a multiple choice question that people want to talk about. Let's have a quick look at them on screen while we're doing this. We've got a, focus, there you go. We've got a cubic polynomial equals 3000. We've got products of square and cube numbers. We've got some graphs up here with some kind of sine thing going on. We've got an area between some parabolas. We've got sine and cosine added together. Oh, it equals 0. And here's another trig expression. You can make that equal 0 as well if you moved over to the right hand side. Some stuff with logarithms. Some stuff with square roots that I put in the thumbnail. But of course, the thing that's winning the poll is not these increasing functions, it is the triangle question. It's the triangle question. I want to know, does our referee immediately get the mail after we send the request? What's the whole process? If you're asking about UCAS, I think the process is that you press the submit button and then the referee can press the submit button. I have no idea whether they get a notification or not, or whether there's a bit of time delay in between those things. If you're wondering whether you should submit your UCAS application on the last possible moment, I think the answer is don't do that. Give your referee a bit more time just in case. Also, it's just polite, isn't it, to give people a bit of time to do a thing. Hello, C, or possibly SEA. No, let's go C. Yeah, C says they say it's her first time joining live. Being live means that things like this happen, where you get to appear on screen, except you're behind a pole at the moment. We'll get there. Was MAT 2020 a bit easier? Who knows? Right, we're going to do this triangle question, I think, and then maybe the H one afterwards. I'm going to stop that poll. Hey, there's C on the screen. Good, right, okay. Would the long answer questions normally be based on logic and combinatorics? You mean this year's questions? I cannot tell you what this year's questions are, I'm really sorry. Okay, here's a question about an equilateral triangle with centre O and side length 1. Or is this going to be a good picture or a bad picture? Let's find out. That's not too bad. Side length 1, not 7. A straight line through O intersects the triangle at 2 distinct points P and Q. So the thing we're supposed to imagine here is a straight line that goes perfectly through O without missing and meets the triangle at P and Q. And I suppose we're imagining different angles that line could be at, but because of the symmetries of the triangle, right? Some of these different angles of that line, we're not told the gradient of the line or anything. Some different possibilities are going to give the same length for PQ. For example, if I need an angle, so I'm going to say let theta be the angle above the, what do I mean? What am I saying? What am I saying? Do I want to call it theta? I kind of want this angle, right? The angle that is above the x-axis. But I don't quite know how to say that. I suppose PQ makes an angle. I suppose PQ makes angle theta with the x-axis. So sort of somewhere along here there's an x-axis and there's some sort of theta above that x-axis. Okay, so theta equals 30 degrees, theta equals 90 degrees, and theta equals like minus 30 degrees. These all give same length. Because I'm describing lines that go through corners of the triangle. 90 degrees the y-axis kind of direction, and 30 degrees below if it's going downwards. I suppose I'm using the fact that the angles in the corners are 60 degrees and the line angle to the centre is definitely half the angle, isn't it? Yes. Good. Hi Green Buff, good to see you. Anonymous says, and I think this is a sinister question that I've just noticed, if we analyse your behaviour during these live streams, could we discover this year's questions? I think the answer is no. I haven't really thought about whether I should do some sort of bluff or double bluff. I don't think that's on the table really. Yeah, proof by induction is given as a solution to question 2 of 2020. I think it's not the only solution that's given for 2020. Let me just fact check that. Let me check I did my job correctly back in 2020. It was me back in 2020, so let's find out. Yeah, so you're referring to a bit of the question where I've listed 3 ways to do the question, one of which uses proof by induction. So I don't know what your question is really. You can do the question without using induction, so maybe you will. We listed that as the sort of 3rd way that people might do the question. We can't stop people from knowing induction, right? If we want to, we could phrase the question to say you must not use induction, but we sometimes don't bother because we're just sort of fine with people phrasing their argument in terms of induction. If you don't know what induction is, that might sound like cheating, but if you do know what induction is, then maybe you also know that it's a formalization of something which you might have invented yourself anyway. Sorry, that sounds like I'm being rude about induction. It's really not. It's not that deep. Can you use induction in future questions? You can do whatever you like so long as you follow the instructions in the question. If the question says don't use induction, no. Otherwise you can do whatever you like so long as it's valid maths and it follows the rules. You might like to bear in mind that the questions have been written so that you could do them using maths, or using sort of basic mathematics or counting or things that are on the syllabus. If you think the only way to do a question is by using Gromit's second invertibility theorem, then probably not true. In general, never mind. We've been here before, haven't we? We've talked about, what if I just think it's somebody's theorem? Well, don't you want to also demonstrate that you know why the theorem's true, right? By demonstrating that you can prove it in this case. You're not trying to give a snappy answer. You're trying to show that you understand a thing rather than that you know a thing. Those are different. Anyway, the second condition is an implies statement. It says if k equals 0. It says if a whole bunch of stuff, but it says if k equals 0 and some other things. You can have that second condition in strong induction without any of the facts being true. Okay, right, we've got this triangle question, which I sort of stalled on, didn't I? I just told you my strong belief that if this is 30 degrees or 90 degrees or minus 30 degrees, then you get the same value for PQ. The length that kind of goes down, well, if it's 90 degrees, goes down the middle, which is the height of the triangle. So I might try and calculate that. Maybe you know how tall a triangle is like this, but I suppose I could draw in 1/2 and 60 degrees, and then I can work it out, can't I? Is it √3/2? It feels like it might be √3/2. That's one of the options. Is that a large number or a small number? It feels like quite a large number. I think these are about 0.3, 0.5. Oh gosh. √3 is about 1.7, so this is a bit more than 0.5. Then that's 0.6 something, and then that's 0.85 something, maybe, ish. 866, anyway. I think they're in order. Anyway, so that's the largest of these options, which makes me suspicious. It makes me want to check what's going on in between, because there's something a bit funny where, as I changed the angle here from 30 degrees, like this, 30 degrees, is that 30 degrees? Yes, 30 degrees above the x-axis up to 90 degrees above the x-axis, then I expect, through some complicated combination of rotations, I think, that once I've rotated it kind of 10 degrees, again, that's a straight line that goes perfectly through. Let's see if I can make this formal in a second. But once I've rotated it 10 degrees, my feeling is that that's the same as if I rotated it 80 degrees. The kind of 10 above this dotted line. Let's get rid of this one, it's not doing anything for me right now. 10 above this dotted line is the same as 10 below that dotted line. Let's see if we can make that formal. I think those lines have got the same length. Yes, let's see. So if I turn my head sideways and I have this as the top, then plus 10 degrees more around, so it was at 30 degrees and then 10 degrees more, or minus 10 degrees down from here, has this effect. So you see these straight lines? They deviate from those dotted lines. I'm imagining changing the angle here. Either I could start at the, let's do it your way around. Either I could start at 30 degrees up and increase by a little bit, or I could start at 90 degrees and come down a little bit, but those are the same. Those are the same length. Because if you turn your head sideways, there's a mirror symmetry line through this corner and O. So 10 degrees down is the same thing, the same distance as the line that you get from coming 10 degrees up from 90. That means the function's got a symmetry, the kind of lengths. That if you get as far as 90, you get back to the same answer. Between 30 and 90, so axis, this little graph here of length, the thing I'm interested in, between 30 and 90, I don't know, some distance or something, as you change here, maybe it's getting shorter, it'll also change over here. So there must be a kind of symmetry going on, and I should look in the middle at a kind of 60-degree line, which is parallel to one of the sides. So I think I'll look at the one that's, you know, right in the middle, straight parallel to that side. It's probably easier to do the sums if I think about it being parallel to the base, but then you can do a bunch of maths and work out that I think that has length 2/3 if you chase some angles around, which is less than root 3 over 2. In fact, that's the minimum. It does come down and come back up again. How much time should you spend on this question? You should spend as long as it takes until you get to the right answer, because it's a past question. So you should keep doing it until you're satisfied that you've got an answer and that you understand it and that you've thought about the question. And then you should keep doing the question a little bit, because you should think about what was going on here. There's a calculation that I haven't done on the screen, which I'm leaving for you. But because it's a past question, you're not under exam conditions, and you're not under a kind of time limitation here. I've kind of ruined it now by showing you some ideas, but in general with past questions, my main advice is that you should spend all the time until you get to an answer. Not like 6 minutes or something silly. Okay, in the actual exam, in the actual exam there is time pressure, and you do have a time limit. Okay, oh, I missed loads of stuff. Oh, I'm really sorry that Gromit's second invertibility theorem was made up. I've learned the hard way that when I do that, when I do that sentence, I have to use made-up maths. I have to use made-up maths, otherwise people think, oh, maybe that's a clue, and I should learn that. So sorry that you went and looked it up, but there's no such thing as Gromit's second invertibility theorem. I don't know. Sorry, that's my idea of a sense of humour. Sorry. What else have I missed in chat? Would the minimum be parallel to the bottom? Good thing to check. Yes, that turns out to be correct. How much would knowing the chain rule product rule help with the MAT? Ideally, it would help you not at all, because it's not on the syllabus. So the questions are designed so that you can do them without using the chain rule or the product rule. And I think a good question design is one where the people who have met the product rule don't have an advantage over the people who haven't met the product rule yet. Right? So I think a good question design is one where you don't need that. There you go. There is a if you want to practice one, there's a practice one in the correct format. What do I do? My personal statement needs a lot of work. Dispute. I doubt it needs that much work. Yeah, I would do Matt. I found out I can highlight chat message bits. Look, there you go. James, what do you suggest? Okay, maybe that's annoying. There's Matt. What's the most exotically named theorem? Oh, that is a really good question that I shouldn't think about now, because I'll have to think about it for ages. Ooh. WK, is there a theorem for WKBJ? The one that, the kind of massive team effort. I've got distracted. But it's good. Oh no. Theory. Oh no, this is not going well. I'm trying to Google it. WK. Oh no. KBJ. WKB? Yeah, this one. Oh, it's an approximation. It's not a real theorem. I think it's good. It's sometimes called WKBJ or Wenzel-Kramers Boolean, or also Liouville-Green, and sometimes people put the LG in there as well. So it'll just be like 5 mathematician names, which I think is good. Exotic in the sense that it's a kind of Avengers Assemble kind of name. Right, good. Okay. The answer to this one, by the way, is 2/3. You want this to be 60 degrees somewhere in the middle, and it's sort of a test of spotting this kind of symmetry, in this way that the function is very complicated the first time you think about it. The function actually repeats itself quite a lot. It's got periodicity, and also it's got a symmetry that increasing in one way is the same as twisting the other way. Maybe that's another way to think about it. So plus 10 degrees and minus 10 degrees from here, I think, is also a symmetry. I can't quite imagine that one in my head, so I'm going to draw it. I think these have the same length as well, but I'm struggling to see that one. Equilateral triangle is a pretty nice triangle. There's a request for H as well, so we're going to have a quick look. Oh, it is this one. Oh, this is good fun. This is in the thumbnail. Thank you for voting for the thumbnail question. This is the right angle triangle, isn't it? The side lengths are positive numbers in geometric progression. So there's 2 ways to do this, really. You could assert that your geometric progression has r greater than 1, in which case then the long side will be over here. But geometric progressions include these ones where the numbers decrease, right? Maybe that's a learning thing for this question. It doesn't actually matter very much for this question, which is a little bit annoying, because you end up with the same pair of solutions anyway. There's another possibility though, right? That I labelled them like this, that there's another possibility where the sides could be the other way around. And the challenge at the start of this question is to work out that there are at least 2 possibilities. I'm drawing it as if it's 4, but there's actually 2 of them. There's pairs, they turn out to be the same. So I'm drawing these 4 versions of triangles on where I label the sides differently for these arithmetic progressions. In fact, you can relabel the right-hand ones, that those are also geometric series with 1 over r, so we're going to get... It doesn't matter. Right, okay. Either way, you've now got a right angle triangle, you've got 3 sides, you should probably write down some sort of quadratic formula to try and solve for r. Well, let's hope it's quadratic, because Pythagoras says square the sides, so I hope it gets something quadratic. I suppose it'll have r to the 4 in, and r squared, so could be worse. Yes, we're doing theorems with funny names. Maybe let's not do theorems with funny names. Ooh, mirror image of a point in the line. I think I have seen a formula like that, I'm afraid. But I think that sort of activity is good for you. So I think it's been done, but it's good to do that sort of thing, especially because then later on, if you find it again, for the mirror image of a point in the line. Okay, let's just do this calculation kind of quickly. So for example, in this case over here, this triangle, I might write down that AR squared, hypotenuse squared, is the sum of the squares of the other 2 sides. And then the a squared cancels, and I get something like r to the 4 is 1 plus r squared, which looks impossible because of the r to the 4, but then I remember that I could write that as r squared squared. And then I've got down to some sort of quadratic for r squared. So this is going to be lovely. 1 plus or minus root b squared minus 4, 5. I'm having a great time over here. I'm definitely going to get some solutions. It feels like 4 solutions, of course, because I still have to take a square root to get r. I can see some numbers coming together. I do want tan, so in my picture, tan BAC is this angle, so opposite over adjacent is going to be r. So is it r that I want? Good. Feels like I'm going to get 4 numbers, so I'll have to think a little bit about positive, negative, real, imaginary, maybe, or I want real numbers for tan. Good. Okay. Oh, chat says, how do you get the 2/3? So I'm going to jump backwards and forwards. If you try the other cases, you get the same equation. It's all very nice. You have two solutions though. And if you like the solutions come from, oh no, so you get also a solution over here. You don't know if you want R or 1/R. Yeah, that's it. The side lengths are positive, so I want the positive value of R, and I have to take the square root of the positive number out of the two of these. So at the moment that's one solution. The other one comes from thinking about how in this sort of diagram down here, tan theta in this case is 1/R. So it's a sort of unusual reason to have two solutions, that either theta was this angle or kind of maybe it was that one over there. Which way round are A and C? It doesn't say in the question. There's nothing to distinguish A and C. And then weirdly, this case on the right turns out to give you the same solutions again, so nothing different over there. You can set A equals 1 if you like. Nobody says how big these triangles are. You can measure them in your own favourite units. The A's cancel out. I actually find it quite reassuring that the A's cancel out over here. I know that they should cancel out. If they didn't, that would be a clue to me that I'd written down Pythagoras wrong. Pythagoras' theorem, it has to work like that, doesn't it? This thing has come up before, right? 1 plus root 5 over 2, that's a number we've met before. Oh, we're not keen on some of these. Yeah. So when we were writing this question, we weren't sure whether, is it okay to write this in the question? I mean, it's not correct, it's not the right answer, but also, this isn't even a real number. A couple of these involve this one as well. Like, that's not even a real number. Sorry, the bit in brackets is, but the square root of that isn't even a real number. So I hope no one picked that for these, because, well, besides the positive real numbers, right? So tan should be real and positive. So I suppose the ones with the minus signs are also out. So you could eliminate several options here by eliminating no because that's not real, and no because not negative, and then really the answer seems to be, do you want root 3s or do you want root 5s? So maybe you can get through this question as a multiple choice question without engaging with Pythagoras, but I think you should engage with Pythagoras. Pythagoras is good for you. A and C are very subtly different. They look the same. Except for that 1 minus root 5. Maybe that's a clue. Anyway, 3 of them have got 5s in, 2 of them have got 3s in. Right, okay. I need to get better at the options. Somebody said, how'd you get that 2/3? So I just want to do that calculation quite quickly. If I'm honest, it's a fact that I remembered from messing around with equilateral triangles before. A bit like the fact that I sort of know the height of an equilateral triangle and the area of an equilateral triangle, given a side length, because I've had to do them a couple of times. I happen to know that the centre is 1/3 of the way up this line. Shall we work out why together? I suppose one way to do this would be to mark in some side lengths. So let's put in this thing. The thing is that you could draw these perpendicular. What am I saying? You could draw in these angle bisectors. Equilateral triangles are so nice. You could draw in this 30-degree angle, right, to get up to the middle. And all I need to know is where that point is. Where's the middle? Because, well, behind the scenes, I'm trying to do that green line kind of goes through the middle. So I want to know how high up it is, because I want to know this line. There's a similar triangle at the top compared to the whole triangle overall. So I suppose I just need to know where the centre is. How high up is the centre? And that will tell me how long that green line is. If the centre is very high, the green line is very short. If the centre is very low, the green line is very long. So that's kind of the control parameter. I kind of picked it because it was a fact that I remembered about equilateral triangles. There are other ways of thinking about that line, I'm sure. To do with, well, the 60-degree angle seems relevant. And I suppose at some point you're going to need to know where the centre is relative to the corners. Maybe you end up doing something like this. I'm stalling for time. Here we are. Because I need to label in 1/2. Equilateral triangles are so nice. And then over here, I have this interesting question to think about. Tan 30. If I got this right? I think I've got this right. Yeah, tan 30. So I need to divide by root 3. Yeah, divide by root 3. Correct? I hope. So then this is sort of that far up, but the whole height is root 3 over 2. So that is 1/3 of the way up. That's not a very elegant number, is it? In there it says 1 over 2 root 3 in terrible handwriting, which is root 3 over 2 times 3. So if you know the whole triangle is root 3 over 2 tall, this is 1/3 of the way up. That's a fact that you can use whenever you like, and I don't just mean in math, just now it's a fact that you know about equilateral triangles. The middle of an equilateral triangle is 1/3 of the way up the triangle from the base to the top. Other ways to prove that? People know that? The centre is not halfway up. Yeah, I know. It's annoying, isn't it? The centre is not halfway up. I think the triangle has betrayed us. Maybe there's another way to do that using centre of mass arguments. People are not going to want centre of mass arguments, are they? No, there's probably other ways to work out that it's going to... The centre's a bit lower down because that's also the centre of mass of the triangle, and the triangle's wider at the bottom, so there's more triangle down there. The centre of mass has come down a bit. Right, good. People didn't want to hear that, did they? There's an excellent question for pentagons. I have no idea. Please go and work that out. That sounds great. Quick sketch of what that would look like for pentagons. What a good question. What a great sketch of a pentagon I've done here. What's that going to look like? Well, hard question. You're going to need to work out how tall a pentagon is. I don't know that. And then you're probably going to want to send a line into the centre of the pentagon down here and work out that height. That seems a bit more plausible, except do you know tan of 54 degrees? Not sure I do. Something involving the golden ratio, I think, maybe, or something weird. And the height's also weird. Maybe it is 2/5. That'd be a great fact if true. Right, good, okay. I've got some homework. Yeah, there you go. And then conjecture, someone who's willing to just go conjecture straight off they go. Here it is, 4/9 of the way up a nonagon, and so on. That's brilliant. That's like Waring's problem. We're going to do a quick vote, and I'm going to show you Waring's problem. Quick vote for a long question. What does Waring say? Can I get the quote? I just want to get the quote, I think. It's a sort of Waring has this conjecture, which is just sort of 2 or 3 numbers with no sequence, and then the words "and so on," which I think it's Waring. Oh, I might be wrong. Let's see if I can find this. Oh, definitely, I've been to a talk on this, I think, or I've been to a talk on something else. How are we going to know? Here it is. Well, the text is a bit small on this page. So the setting is things like Lagrange's theorem says that every positive whole number is the sum of 4 squares. That's a good fact, not an easy fact to prove. What if you have cubes or higher powers? How many do you need? Waring claims, without offering proof, that every positive whole number is the sum of 9 cubes or 19 fourth powers, and so on. You're not expected to be able to spot a pattern in the numbers 4, 9, 19. You must have gone with that experimenting. There you go. The talk that I went to was by Vicky Neal, and I'll put this link in chat in case people want to read about that. That is not relevant to Matt. Just what I can sort of sense happening is that people would like something different. For fun, not for Matt. So if you're in need of some other sort of mathematics that's just not really, not really Matt at all, then there you go, there's a link. Right, 2/3 squared, says Kay in chat. Brilliant. Did we have a vote going? Did I cancel a vote? I never started the vote. You would have let me know, right? Here we are. Okay, good. We got some voting going on. You can vote for multiple options. I think someone may have voted for most of the things. 2, 5, 6, 7. Is that a 2, 5, 6, 7? That says maths and computer science, right? No, that says computer science. 2, 5, 6, 7 is a computer science. Yes, very quickly in Slido. I see you and your computer science preferences. That's okay. So fast as well. Right, 2 and 5 are doing well. The ones that everyone does back in 2019. Back when we attempted to have different questions for computer scientists. 2, 5, 6, 7. Right, good. Where are we going? We're either going 2 or 5. I'm going to let you vote for just a second. Right, just a moment. I'm back. Yeah, so in chat, I know your and so forth had a bit more to it, right? Greatest fraction base with denominator n that's less than or equal to 1/2. That would be cool because then it would get closer to 1/2 for large values of n, which feels about right. For a large value of n, it should be in the middle, right? Like the middle. You know, show me this 1,000-sided shape. Yeah, that's probably better. I'm not sure it's correct because I think it's really horrible for a pentagon. I haven't quite worked this out in my head, but I think it's horrible for a pentagon. There's two things to do, right? If we do the pentagon case, conjecture, if it's horrible, then all of our nice conjectures are out the window. But if it's nice, then that's, I think, quite good evidence. There's no, I sort of think we've benefited in here from 30 degrees and 60 degrees being quite closely related. With 60 degrees controls the height of the triangle, 30 degrees controls where the centre is. Those are obviously related. Oh, what am I talking myself into doing? We're not doing that question. Right. Okay, I think questions 2 and 5 have both got 69% of the vote, so I think we're going to stop there. Nice. So question 2 from 2019, let's have a look. There is an enormous polynomial in this question. Just going to zoom in. There it is. Huge. There's an enormous polynomial in this question, which is formed by multiplying together these little binomial terms, 1 plus x squared plus 1 plus x cubed, and so on, up to 1 plus x to the k. And there's some easy-ish bits at the start to work out the degree, right? Because it's x to the 1, x squared, x cubed, and so on, gives you the highest power. Plus k. That's how you get n. Oh, and we know that one, don't we? That's k plus 1 over 2. And then this, whenever it says by setting x equals 1, or otherwise, otherwise means you can do other stuff if you want to, but the question's been designed so that you can do this. So it says explain why, so I think I would explain that pk of 1 is equal to 2 times 2 times 2 times dot 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 times 2, because of, I can put 1 into all of these brackets, and pk of 1 is equal to a0 plus a1 plus an. Oof. So then I need to interact with the idea that there's a max. What's a max supposed to be? Oh, I see. Where a max denotes the largest of the coefficients. So I need to write down an inequality, and maybe this is overconfidence, but the thing I like to do is to just try and write down a true statement. I'm not aiming for the thing in the question, but I'm trying to aim for a true statement. I have this fact about all the a's, and I would like to write down a true statement about a max. So what can I do? Well, a0 is less than a max, because a max is the largest. I guess they could be equal if a0 is equal to a max. And I can say the same thing for a1, and the same thing for a2, and so on. How many is that? That's what, there's so many under chat. That's n plus 1 lots of Amax. And then the dust settles, and I look at what I've got. I've got on the left 2 to the k, 2 to the k. K is the number of brackets. And on the right, I've got n plus 1 Amax. And that's large. So then that's brilliantly, this just rearranges to be the thing in the question. So I have this kind of mix of, I know that we have to involve Amax somewhere, I have to get it involved. And all I know is that it's larger than or equal to each of these coefficients. So I kind of have to do something like that. So it's 2 to the k because you can plug in x equals 1 into all of these brackets on the left. So this would be 1 plus 1, and this would be 1 plus 1 squared, and 1 plus 1 cubed, and so on. 1 plus 1 to the k. All of those brackets are 2. Okay. YouTube's asking you somebody to sign in and to wipe cookies to get back to the video. I don't know what that means. I've never wiped a cookie. Maybe I should wipe my cookies, but sorry that YouTube's giving you trouble. Hi Aaron, everyone did senior, not everyone, but lots of people did senior maths challenge today. They had a chat earlier. If you scroll back through chat or sort by popular, then you might see people's opinions about SMC. Where did you get that Amax inequality from? Well, the only thing I know, right? The only thing I know is this. Down here I've got a sentence, so in my head I've tried to convert this to a maths, right? Where Amax is the largest of these coefficients. That means that it's larger than this, it's larger than this, and so on. I mean, also it means that it's equal to, I know that maximum means it's equal to one of them at least, and also all of the other inequalities. But if I'm doing a comparison between what I've got, which is all of the A's, and I just wanted something clean involving Amax and none of the others, then I need to do some sort of replacement, I think. I need to have some sort of bound on this sum, if you want to think about it like that. And that sum's bounded by, well, worst case scenario, I suppose. All of them are Amax, all of them are huge, and equally huge as each other. Anyway, yeah, okay. Which is true, isn't it? That each of them is individually less than or equal to Amax. So their sum of all of them is less than or equal to, you know, most n plus 1 times Amax. You could redefine all of those, you could rearrange those all to be ratios or fractions, if you want to compare each of them to Amax individually, and then multiply up at the end. That works too. Yeah, okay. Why is it n plus 1 and not n on the right hand side? I had to think really carefully, and it is because of, wait for it, this. These a's start at 0, so there's an extra one at the front. There it is. This is n of them, and that's one more. You've got to watch out for these sequences that start at 0. It's a thing that some people do. Okay. So later on, explain why the value of AI eventually becomes constant as k increases. Ooh, interesting. Okay, as k increases. Oh, I see. So as k increases, what actually changes? So, you know, you work out pk, and then you want to work out pk plus 1. What do you actually work out? Well, to go from pk to pk plus 1, you have an extra bracket. You need to multiply pk by, and then it's 1 plus x to the k plus 1. You need an extra bracket. But of course that x to the k plus 1 only affects massive powers of x, only ones where the exponent is huge, if k is some large number. So that won't affect the coefficient of anything smaller than k plus 1. The coefficient of the term with x to the power of something that's at least as large as k plus 1. Those ones change and the smaller ones don't. I didn't say that very well. Let me try again. When you multiply a polynomial by 1 plus x to the k plus 1, with k a huge number, then obviously the polynomial changes, but you get a copy of the polynomial, that's what the 1 times does, and you get a copy of the polynomial multiplied by some enormous power of x. So looking at the coefficients for small exponents, they don't change. So AI will be constant as k changes eventually, because eventually these terms don't change that coefficient. Okay. In chat somebody says, would you recommend doing the 1996 to 2006 papers? No. We haven't put them on the website because the test was quite different back then. Some of them are on the internet. I don't actually know if the ones on the internet are all true. I sort of assume they might be, but I don't really recommend them. There are other things you could do. There are other sources of tricky problems that are, you know, a bit more linked to current curriculum, perhaps, or a bit more challenging in other ways. That's probably good for you. Just because the exam says mathematicians test at the top doesn't necessarily mean that that's like spot on, right? Anyway, okay. There's this complicated bit at the end, right? Where the student has this guess that the coefficients have this nice symmetry to them. Oh, there's symmetry again, right? And that's true. And when it says by substituting 1 over x for x, they're imagining that you do that in the definition up at the top. So this is one of those exercises where, well, where are the x's? They're not in here. You have to look all the way back. Well, up here? No, gosh, no, that's just for 6. So in here would be awful. But up here, if you substitute 1 over x in here, so you're evaluating the polynomial not at x, but evaluating it at 1 over x, then you get, well, you get a whole sort of consequences, don't you? You get different things in the brackets, and you get different things on the right-hand side, but they're equal. So we've got an equality there. And if you're lucky, you can turn that equality into a statement that has something to do with coefficients the other way around. Let me quickly show you something on the right-hand side. I'm not going to do that whole part of the question, but just quickly. So if you plug in 1 over x, have I got space there? Yes, I do. If you plug in 1 over x, you have this, and that's equal to, if I put it over a common denominator, so look at this. If I put it over a common denominator, I have a polynomial up here where the coefficients go a0, a1, a2, but the powers are now decreasing instead of increasing. And that's the key. Which year did you give the math? I've never done the math. I've been in charge of the math, but I've never sat the test. What are the sorts of tricky math questions? We've had a list. There's some recommendations on the MAT website, but just to save you a click, we quite like A questions if you can find those. Step questions if you've learnt the topic for the step question, because some of those things are based on more advanced maths. I personally like Enrich. It's not a maths test, but it's got other activities and games and puzzles for you to try with some real challenge in there. And if you're a computer scientist and you'd like some tricky problems where you need to work together with a computer, then I really like the Project Euler archives. So you sort the oldest problems first. That's a website with just free tricky problems that you have to think about the maths first and then write some computer code afterwards. So I like those for tricky things. And also, depending on where you're watching, your country might organise things like UKMT challenge. Some people have done the senior maths challenge today. There are also things like BMO. The UKMT is a maths trust in the United Kingdom. They put some of their papers online, so you can get some sort of tricky maths problems out of them. They get very difficult very quickly. Probably harder than most math questions. You could even do, Aaron in chat, you could even do the PATs. You could even do physics if you like. It's up to you. There's not much. It's different teams working on maths and PATs behind the scenes. You shouldn't go into PAT thinking, I'm going to really, I'm going to find out what the same people have been, the questions are written by physics department there, and materials and engineering all working together. Whoops. Okay. Right. Last part, very quickly. The student guesses that all whole numbers appear among the coefficients, but this is wrong, and we're told to use part 2. Now, part 2 said that A max was not that big, or did it say it was A max was large? I can't remember. Let's have a look. Oh, it said A max is large. Larger than or equal to 2 to the k over n plus 1. And recall, we know that n is k plus 1 over 2. We haven't had to use that yet, but it's a fact. So the student says that all of these numbers appear among these coefficients. And the idea is the student is wrong because there are lots of numbers and not many coefficients. We know how many coefficients there are down here, right? There's n plus 1. In fact, we know from the previous part that there's some repeats. So maybe you could divide by 2 if you like, to say, there's lots of repeats. You might worry about being out by 1, depending on whether n is even or odd. So let's not go there. There's at most n plus 1. It's really not that many. Maybe only half as many, but whatever. At most n plus 1 of these coefficients. And there are loads of numbers in there. It has to work like that, I think, because the information we've been given is that A max is large. There's a hint for us to think about the fact that A max is large. So and we're told the student's wrong. So it must be the case that we're trying to argue that this thing's too ambitious. Yeah. Okay, if you missed it, it is recorded. You can rewind just a little bit. You could even rewind live. And then catch up with live either by jumping up to the live stream again, or by, I guess, watching at double speed until you hit the bit that I'm saying. But yeah, a little bit. Yeah, and there's something going on with exponentials and polynomials, which I think is what we were expecting. This idea that exponentials grow really quickly. The 2 to k is huge. Even though it's divided by n plus 1, there's n plus 1 over here. So doing some sort of fiddly details, fair enough. You could even work out a point at which, I think if you put in 10, does that work? 2 to the 10 is about 1,000, divided by 10 is about 100. So A max would be larger than about 100 for when k is 10. Oh no. There's 50, so this is not that large because I have to multiply by k plus 1 over 2. Okay, maybe I need a larger number because that's going to be 50, and then on the other side this is going to be 51, so it's going to be pretty close. Maybe I can use the factor of 2 there. Yeah, okay. Maybe k equals 10 might be enough for you to say this is too many numbers and not enough coefficients, but maybe being a bit clever. I think if you try and work out the size of these things for k equals 20 or something, then it becomes more and more clear that A max there is huge, the largest coefficient is really big, and n is not that large at all. Good. Okay, there was also a request for 5, and I've got a little bit of time, so I'm just going to quickly talk about what's going on in 5. It's another one of these questions where we think about recursion. So I'm going to assume you've read the question and jump down to the recursion part, which we'll just look at this just for 5 minutes here. Do more people apply to New College for math as compared to the other colleges because you hold the live streams? Turns out no, I don't have that drive, that kind of draw for students. I wish it was the case that everyone applied to New College. It would make my life much easier. No. Lots of people do apply to New College, but not everyone. Right, okay. In forming an allowable partition of these numbers, so there's some text at the top of the screen to talk about partitions of this. Subsets of at least 2 elements is the thing that we're doing. And here are the possibilities. So we can either pair n plus 1 with one other element, in which case, just my question, if these are instructions to me, if I'm a computer following instructions, then I'll need to know which element, right? And if I'm counting possibilities, then I want to know which other element I'm pairing it with. Maybe there's choices there. I see on the left here, element 5 has been paired with 1, 2, 3, and 4. And then there are n minus 1 elements left to pair up, to deal with. Yeah, okay. Or we can take an allowable partition of these things and just chuck in item 5 into one of the existing subsets, making a subset size 3 or more. So these are 2 different possibilities, and this is going to be quite complicated, isn't it? In that case, it says one of, so again I want to know which. And these are bonus factors, right? There's going to be a big plus in the middle because we've got 2 separate cases for what you might do. In this first case, if you chuck in element n plus 1 with one other element, then removing it would not make a allowable partition. Whereas in the other case, if you started with an allowable partition, put in 5, then removing 5 would leave you with that allowable partition. So these are really different cases. In the first bullet point, removing 5 would ruin things, and in the second bullet point, removing 5, or item n plus 1, sorry, would leave you with an allowable partition. So these are different. Good. Victor is very good. Right. Victor Flynn teaches pure mathematics at New College and is brilliant. Hi Victor, if you're watching. I don't know why you're watching if you are watching. You don't need to do the maths. Right, okay. So we're asked to find an equation for this in terms of 2 things, but I'm not really surprised that there are 2 things because there's 2 different cases and the cases are quite different. So explaining you 2 things, okay. And there's some coefficients maybe because I have these choices about which element. Okay, so in the first case, I think that we have a choice of which other element, so that's a factor of n. I'm going to write times because then whatever I pick for the element to pair this large number with, n plus 1, whatever I pick to pair with that, well, I've got free choice for what to do with the rest. I've got to do allowable partitions of them. I think that's called f. Now, what's k? N and k. N, k. Number of ways of partitioning the set n elements into k such subsets. Oh, I see. Okay, so I could partition it into, no, so I need to partition n minus 1 things into k minus 1 subsets. Because I've used one of my subsets up, pairing up n plus 1 with that new element. That's n choices of how I did it, but now I've got k minus 1, in this picture just 1, more subset to go. And I'm using n minus 1 numbers. Obviously, what the numbers are isn't that important. They're just different labels, aren't they? There's only one way to put these items into an allowable partition in this case, so I only get one thing in each row. Okay, that's a little bit disappointing, just one thing in each row. Okay, whatever. Over here, I have an allowable partition of this. How many of those are there? Well, Fn, and I'm going to write k because the plan this time is to take an allowable partition and just add this to one of the existing subsets, so the number of subsets won't change. And if I'm trying to calculate the number of possibilities where I end up with n plus 1 things in k subsets, then, well, maybe I'll start with k subsets, and I've got a choice now of which one of those subsets I add this new element to. Do I put it in the first subset or do I put it in the second one? Oh, and I see here, so these first 2 kind of go together, don't they? Some of my brackets better than others. Let's have another go at a couple of those. So So 1, 2, and 3, 4. You could add element 5 in here, and you would get this thing. Or you could add element 5 in here, and you would get this thing. So these first two rows kind of go together. Don't know if you noticed that when you read the question. These kind of go together, and these kind of go together. There are 3 allowable ways to put 4 items into 2 subsets, and then doubled up because you have a choice of 2 subsets to put in the new element 5. You could add it into one or the other. Okay, we should add these together. So it's n times that plus k times that. Cool, good. Okay. Hector has done a calculation and it's not anything nice. Yeah, and Rosie points out that I'm a failed influencer, so there you go. Right, good. Okay, that feels like a good moment to take a break. It's another one of those, the rest of the structure of that question, by the way, I've zoomed out. It explains the thing at the start, shows you an example, asks you to explain some edge cases, and then the meat of the question in the middle, forgive the meat-based analogy, I suppose, vegetarian alternative. The heart of the question, not in a meaty way, but in a spiritual way, the heart of the question is this recurrence relation, this thing relating values of f to other values of f. So we get this thing. I haven't written it out, but I want this to be the sum of those previous things with these n and k multipliers on there. Okay, and then the rest of the question is you use this to calculate or to think about a special case at the end, either using your formula or by going back to first principles and interacting with how the question works. I think that's the tennis tournament question at the end, by the way. You've got 2 n things and you've got to put them into n pairs. Yeah, that's tennis, isn't it? When they do a big tennis tournament, they have 2 n players. They have to pair them up. It doesn't matter what order each of the pairs is in. It doesn't matter what order the games are in. That's what round 1 looks like overall as a structure, as a competition. It is time for a quick break because it's 6 o'clock. Oh, I felt like at the start of the stream, I felt like I was maybe about to develop a kind of bit of a cold. Oh, it's coming. It's coming. Right, okay. So a reminder, if you've been looking at the screen for the last hour, remember to blink. I'm going to drink some water. Yes, I am. I'm going to mute myself as well. Right, okay. That was fun. I liked this question. I only did the fun bit in the middle. The rest of the details are for you to do. He's sort of slowly backing away from the question. Right, okay. Good, I like that. What's next? Maybe 2021 because people voted for it, or 2020 because it's next in sequence. What do people want? Let me know in chat what we're doing next. I think remember the vote is 21. If there's any bit of 2020 that we should look at, I'll take requests. Otherwise, I think we'll move on to 21. There was someone in a YouTube comment who says that I should do every question, and there are some past years where I've gone through doing a video for every question. It is really hard work. Sorry, I haven't done it for every past paper. Did I pick one of these for the thumbnail? I probably did. Oh yeah, I probably picked this one for the thumbnail, didn't I? It's not as bad as it looks. It's really not. For example, at the front here, values of a and b, well, that's when y equals 0. So you get to replace some of the complicated equation with 0. The equation up there is pretty small. I would probably write it nice and large, I think, if I were doing this question. Maybe I would regret writing it so very large right on top of the question, but you never know. The thought process. Question 1J. Let's see if I can do both of those together. Help with your thought process in 2020. Okay, let's give that a go. Okay, so the request from chat is to help with thought process. How should you systematically think in a maths question, bearing in mind that they're unfamiliar and they've got ideas that you might not have encountered before. So for me, first step is reading the question and trying to work out what on earth it's talking about. I might need to draw a diagram. I might need to try some small cases. I might need to try making the question easier to see if I can do an easier version, or just play with some version of the question. I suppose I'm trying to take it apart. I'm trying to fiddle with the mechanics of what's going on. I don't know, maybe that's grandiose of me to compare it to something physical like that, but here we are. What I've read so far is consider a square, and I can't see a square, so I'm going to draw a square. Consider a square. I am considering a square with side length 2. That's my thought process, 2. And centre 0, 0. I kind of know what the centre of a square is, fine. Not my best picture of a square. And a circle with radius r and centre 0, 0. Okay, circle. Is it a big circle or a small circle? At the moment, I don't know. But you see, by drawing the picture, it's forced me to think about the different cases that we might get. In fact, this question is entirely about the different cases that we might get. And you see, as I drew that one, I also thought, not happy with that. Feels like it should be a bit more symmetric. So I should know that it should be more down there. You know, it should come out all of the sides at the same time, shouldn't it? Okay, let A of R be the area of the region that is inside the circle but outside the square, comma. Okay. Inside the circle but outside the square. So I think inside the circle but outside the square. So if I'd only drawn the small circles, this would be a reminder that eventually I get some stuff that's outside. To start off with, there's nothing, right? So AR is 0 for R less than, and I haven't worked out when it happens, but it's 0 for a bit. And I'm at this comma so far, and let BR be the area of the region that is inside the square but outside the circle. My goodness. So BR, I think I'm supposed to imagine like this bit, but there's different cases, right? So that looks hard. What a nice picture. Okay, which of the following is a sketch of A of R plus B of R? So I've got to maybe evaluate these things, or find some shortcut to work them out, or just add them together. So, what can we do? So we could go off and work out a formula for that bit of circle area. We've done that a few times. So now my thought process is, which bits of this do I recognise? And I recognise that bit. That's circle, straight line, a little bit of a circle sliced off the top, or one of the sides if you prefer. We've done that calculation before, so we could do it again, and that would be A of R. We'd also have to maybe think about this B of R corner of a square. I don't think I've done that one before, so I'm a bit nervous about doing that calculation. It looks hard. My next thought is, well, when the circle is small, A of R is 0, which avoids one of those problems for me. On these plots, it looks like it starts at 0. It's not labelled, but it looks like it starts at 0. So I can imagine small values of R. Maybe I could find out what's going on when A over R is 0, when there is no such area that is inside the circle but outside the square. I mean, when does that happen? When does that stop happening? I suppose it stops happening just when the circle gets out to the sides, which is because there's side length 2 and there's a radius. It's when R is less than 1. This is 2020, Rob. I think. So for R less than 1, A of R is 0. Can I do better? Can I say what B of R is? So maybe not in this special case, but in some sort of case like this. Oh, I'm slightly off the bottom, aren't I? There we go. Sort of case like this, where the radius R is some small number, and I'm thinking about the area that is inside the square but outside the circle. It's kind of phrased as if those things might, as if those things might be easily related, but I can't see a way that they are. So this is a rather horrible picture of some sort of square. It reminds me of, I saw an episode of Bake Off recently where they cooked something that looked absolutely vile. But it's a bit like this, the cross-section of the meat pie that they'd made was awful. Anyway, not Bake Off. 1, so this would be area of square minus area of circle. So now I've got something which is if r is less than 1, then the total should be 0 plus 4 minus pi r squared. Which I suppose when r is 0 is 4, so it should look like a quadratic going down. Oh, like this, or like this, or like this, or like this. I'm now looking at the options, right? Not like that, not upwards. Okay, not too bad. Now I'm playing spot the difference. What can I look at next? I guess the tempting thing to look at is these seem to be a little bit different when r is larger than 2 maybe, or getting close to 2. So I could look at r large. I don't know how large I mean, but sort of, is it going like that, or well, these all look a bit similar actually. So my next idea is to look at r large. And actually that helps because there's another picture I can draw where the circle is much larger than the square, in which case it's pi r squared minus 4, which shows me that it should be curving upwards like that or that. Maybe like that, not really like that. Not keen on that. So pi r squared minus 4 for the area of the circle, not the square, in that case, where it's really large. I haven't worked out how large the circle should be, just proper large. Is it square root of 2? I don't know. Whatever. At some point it's like that. And then I've got to spot the difference between these remaining pictures. So is it D or is it B? What's the difference between those? Because it's multiple choice, I can choose where to look. I think the difference is that this one comes down to 0. And this one doesn't. Otherwise, those pictures are really similar. So I think the question is, can you ever have AR plus BR equals 0? So then there would be none of the pink bits and none of the blue bits, which I think is impossible. Not keen, I'm going to write. I don't know, it just feels like as soon as the circle breaks out the sides of the square, you've now got some non-zero value of A. And B is also a positive number or 0. So as soon as that happens, you've now got a positive function. And I think it's going to curve around like it does in D. So I've got to an answer on this question. I haven't worked out the actual function for this bit around here. That's super difficult. Which I think is why this is being listed as J. In the old day. Do I know what these 5 graphs are? Yes, because part of my job this year was to draw those graphs. So you can imagine my horror of realizing that in order to draw the correct picture, we would have to draw actually the correct answer. So I would have to go and work out all of those areas that you don't need to work out for the question, but I would have to go and work out all of those 8 areas around the outside, the curve one and the cornery one, and I would have to plot that function perfectly. So that really is the right way that it turns around from a downwards quadratic to an upwards quadratic. I had to work that out, and then I made up several related things. That's how I made up the wrong answers for that question. But yeah, I really didn't want you to imagine the horror of, if you did any of the calculation for working out the function there, and then thought, that's a really complicated function, then yeah, been there too. What is the function? Oh, it's a whole mess of like inverse sine and things. It's not nice because you don't, in order to find like that bit of area up there, you need to know some angles really, and the angle comes from thinking about inverse sine of inverse cos maybe? Inverse cosine? Because you have sort of 1 to get up to the edge, and you have r over here, so yeah, you want inverse cosine of 1 over r, you know, the classic, which is not a fun thing to sketch. It's multiplied by some stuff as well, because that's just the angle. It's like a hard geometry long question, except people doing the test didn't have to do the hard geometry long question. Only I did. Oh dear. Right. Yeah. Have a look at some special cases, like small r, large r. Right, okay. What I was really trying to do there was illustrate thought process, which at no point involved giving up but we do try looking at easier cases. We try looking at behavior when one of the parameters might be small or large, and we try and build an understanding. I think the only way to eliminate B, I think, is to realize that you can't have both of these things being simultaneously zero, maybe by some kind of intuition. Good. Okay. Yeah, either A or B or both. Yeah, addition of area can't be zero. Okay, right. Super horrible question. So that was a request from chat. I think I'm going to move to 2021. Chat seems to think that 2020 is not that bad. What else have we got? Have we got anything good? Oh, we've got the even odd question. Why is this? Can you do a function? Somebody in chat said, "Can you?" Oh, they were talking about 2021. I think maybe they'll vote for it in a second. This is just solid. This is just good property, good fact presented nicely as a question. There you go. That's what I like in that question. Anyway, 2021, I think. Let's have a quick look at 2020. Rob would like 2019. While we're voting, Rob's requested 2019 B. So we're going to have a vote. Is going to be reset the vote. Reset the vote. Oh, how do I reset the vote? How do I reset the vote? Oh, I have to go over here, don't I? Click, 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 click. There you go. Oh, it's a long question as well. We're voting for 2021. Fair enough. Time for a long question, I think. Hello, James. I hope you're well, says Anonymous in chat. I am doing medium. I'm on a 3-star day. Maybe 2-star. What do you recommend doing after we finish all the MAT pass papers? And I had some suggestions earlier. I do like TMUA for other questions. Math Challenge, if you enjoy that sort of thing, has got slightly different questions. Basically anything that you find challenging, because the real thing that you're trying to practice is being stuck on questions and then doing them anyway, getting unstuck from those questions. Possibly you've got to the point where MAT questions, they've got predictable to you, or they've got boring. You want to practice some other sorts of maths. I also put on screen earlier AEA, STEP, Enrich, Project Euler, just other things that are out there that have other sorts of maths going on. Oh, they are voting for question 7. We just thought Miriam and Adam were quite nice names. They're not anybody's kids. Somebody mentioned stars and bars, which I found useful. Where else would you recommend finding these niche shortcuts? Can you think of any other similar? What do I know? Some people have memorized values of trig functions. I think that's probably a good idea. I'm quite slow on those. Some people, what do I think? Well, I don't have any other sort of counting shortcuts, do I? I don't think I do. If you've got more combinatorics counting, it's really just a standard stuff. And notice, by the way, for that counting question we had a quick look at in 2019, you didn't need to do any combinatorics county stuff at all. There's a request for 1b from 2019, which is this rather nice combination of square numbers and cube numbers, if it loads. There it is. So here the idea is that you might try some of the possibilities, and it's a kind of structure of always, sometimes, never, which is what might or might not be true. Is it a square number or a cube number? Both, neither, sometimes, it depends. You're supposed to experiment for this by trying small examples or playing around with things, right? So a square number and a cube number. So I think an example like 2 squared and 2 cubed, product means you multiply them together. So you get 2 to the 5, which is not square, and also not a cube. So that eliminates some of these, right? Always a square number? No. Always a cube number? No. Never a square number? Well, that's not right either, is it? Because these things could be, oh my goodness. It feels like this cube could also be a square if it's 2 to the 6. Then that's a cube number because it's 64 is 4 cubed. but it's also a square number because it's 64 is 8 squared. So if you have kind of that cube, then you will end up with 2 squared times 8 squared. Possibly I should be using 1 instead of 2, but you know, here we are. Maybe things are easier with 1. Do I recommend learning number theory? That might help more generally outside this syllabus. Not really. Binaries come up a couple of times, but binaries super easy, no offense, computer scientists, but I know how binary works. You know how binary works, right? 1, 2, 3, 4, 5, 6. You know that one, the binary. It's the same as decimal, but you carry the ones way more often because instead of ticking over after you go past 9, you tick over after you go past 1. Maybe you've got binary. Good. If you'd like to see some binary, there's some in 2020 question 2. Yes, question 2. There you go. That was the thing I want to do sometimes, where I zoom out and then go across and find the right question that was in my head. One day I will learn where all the questions are, so I can just go, oh, horrible geometry. Yeah, that was horrible geometry. Oh, yeah, thing with vampires. Ah, not vampires. Where are the vampires? I'm not going to find the vampires. Okay, there was a question with vampires one time. 21, question 4 is winning, which is the cake sharing question. We'll do that in a second. Let's just catch up with chat. Ratio of the height from the center. Oh my goodness, what is going on? Oh, Hector is doing that polygon question. How should I believe this? 1 plus sine x. Yeah, I think I do believe that. If it's side length, or is it like radius 1? I don't know what 1 is. The vampires were, I think, telling the truth and lying, and it was all very complicated, and I'm not sure I believe the solution entirely. Vampires is... Anyway, never mind. Should we read this question together then? Here we are. In chat. In chat, before I move on. 1 squared times 1 cubed. That's such a good example. I knew that 1 would be better than 2. That's a square and a cube. That's brilliant. I think then you're done, because then you know it's sometimes and sometimes. 1 squared times 1 cubed. Print it. That's perfect. Last live stream, I've got 3 more papers to go for next week. Oh, I missed a bunch of questions. Yeah. What's your least favourite math question? It might be the vampires. I don't know. The vampires is the one that I disagree with a little bit. I think it was the last time they did a truth and lie question. Is that fair? Yeah. Okay. I think I'm happy going on the record as saying the vampire one is my least favourite question. Oh no, that's going to get thrown back at me, isn't it? Yeah, there we go. James says that, oh no, never mind. Okay. Right, here we are then. Charlie is trying to cut a cake, says the question. The cake is square. The cake is a square with side length 2, okay, and its corners are at, predictably, 0, 2, 0, 2, and 2, 2 over here. Charlie's first cut is a straight line segment from the point xy to x0, where x is somewhere between 0 and 2 and y is somewhere between 0 and 2. So they cut this. It would be a really good idea if those numbers are both 1. Charlie plans to make a second straight cut from the point xy to the point 0k, somewhere on the left-hand edge of the cake. This will make a slice of cake which is bounded to the left of the first cut and padding below the second cut. So that shaded area. And the question asks us to find the area of that slice of cake. The aim here is to get a slice of cake that has area 1/4, because, well, you can do that if it's 1, 1 in the middle. You just cut the cake normally. That's what it says, right? Verify that if x is 1 and y is 1, then you've done the first cut in the kind of normal way that you would do if you were sharing a cake between 4 people. And then choosing k equals 1, go to the middle of that side, really should give area 1. Yeah. Find another point such that choosing k equals 1 gives a slice of cake with area 1. Oh, fun. Okay, right. So this is one of those algebra geometry mixes where you're presented with some geometry, but you find yourself doing a lot of algebra. In this case, the algebra involves inequalities as well. I have those groups together in my head, I think. Algebra, inequalities, whatever. the inequalities here are going to come from the fact, well, we have some inequalities for x and y, we have some facts about k, don't we, maybe? We think that point is somewhere on that side of the cake, for this to make sense. So I think we'll end up writing down some expressions and then quite quickly converting this into an algebra problem. I just feel like the cake is not long for this world. We could integrate, or we could use things like the area of a rectangle and a triangle. Different ways to do this, I suppose. Triangle, triangle. Oh, I like that one. I haven't done that one. I'm going to do that this time. Triangle, triangle that way? No, that's mad. Well, mad is maybe a bit strong, but oh, I don't like that one. No, I like this one. I would probably, in an exam, I'd probably do this. I don't know, I just like right angled triangles. That's a bit of a weakness of mine, isn't it? That it's not hard to find the area of a triangle like this if I know the base and the height. My preference is just right angled triangles. Let me know in chat how you would cut up this slice of cake in order to find its area. I'm going to have a go at joining it to 0, 0. I tried a couple of ways to dissect the cake, and I've settled on this one. So this height is y, this side is x, so this area is xy over 2, and then over on this side it's got height k, it's got width x, so it's got area kx over 2. So the area of this slice of cake is xy over 2 plus kx over 2. For this top bit of triangle, I'm imagining that this to be the base, and the perpendicular heights to be that way. Okay, I'm going to check my answer by doing it another way, which is to chop the top off. If I chop the top off, then I have a rectangle down here, which is xy, and I have something up here, which is x times k minus y, and it's a triangle, so divide by 2, yuck, I still get this xk over 2, and I still get, oh gosh, xy minus half xy, I still get this. Okay, final answer on the screen. Both ways giving the same number at the end. I did that on purpose. Yeah, I think the person in chat knows what I did, but yeah, okay. We had someone. I think they're not going to find out now. We had very old questions which mentioned Charlie. Charlie is from an old question in a way. There's lots of questions with people wearing hats that we saw a long time ago, or writing numbers on each other's heads, and I think in a very old MAT livestream, I assumed that Charlie was a man, and somebody watching pointed out that that they personally were called Charlie and not a man, so we couldn't really tell. So that made me try to make it careful that when I write a question about Charlie now, yeah, could be a man, might not be a man, who knows? Good. Hector, you can email, well, you can use the contact button if you like. Yeah, I'm not going to go as far as to say it's useful to me, but I am a bit interested. So go for it. Trapezium. People in chat know about trapeziums. Look at all these trapezium enjoyers. Look, area of a trapezium. Trapezium. It's a trapezium. Look at them go. Ah, right. How does that work? So you say something like 1/2 times a plus b over a plus b, so like y plus k times x. Hey, that's nice. Maybe I'm a trapezium enjoyer. Oh dear. Right, okay. Are we having fun? Yeah. So choosing k equals 1. If all of these numbers are 1, then you get 1/2 plus 1/2 is 1. Brilliant, that's a slice of cake with the correct area. Find another point. So maybe I can move xy up here or something. I suppose if I choose a value of x, I have to be a bit careful and then think about y. And then crucially, I think the only idea here for part 3 is that we must have 0 less than k less than 2, maybe equal, but k between 0 and 2, so that that point is somewhere on that edge. So that it's not over here, off the edge of the cake. We must have that. And then these inequalities for k turn into inequalities for x and y. So if you have this like area fact up here, in general it's this, but in particular, if you want a slice of cake with area 1, so area equals 1 if this sum is 1, so then you've got an inequality for k, and you've also got a fact about k. You know, after rearranging this, that says something like k is equal to 2, I'm trying to multiply up, subtract the xy, and then divide by x. Gosh, I know people in chat don't like it if I do too many steps all at once, but you can solve that for k, right? There's a k on its own in this equation you can solve. I hope I've done it right. Anyway, so you have this kind of expression in here, right? So when we have this true fact about k, it's between 0 and 2, and we have some way to translate that into x and y. And then it's a matter of rearranging, I think. Being a bit careful about the fact that x and y are both positive numbers. So we'll be a bit careful with the signs of our inequalities, but that's fine. And there's a sketch. And for the sketch, we need to convert these things, don't we? So we need to think about how this one, for example, is y less than or equal to 2 over x. And this one, there's going to be some sort of transformation going on because it's y greater than or equal to 2 over x minus 2. So we could sketch some curves with these 2 over x curves. Yes. Good. So it's a bit of a sketch, but that can't be too bad, right? X is still positive, so I'm allowed to divide by x to get these kind of equations. I like to rearrange my equations when I'm going to sketch them for regions involving y. Okay, Charlie may instead plan to make a second straight cut from xy to a point M2 on the top edge in order to make, and then it's a slice on the left, sort of. We've done something a bit like this before. It's not quite going on in this question, but you sort of imagine Charlie making this first cut and then thinking, uh-oh, and rotating the knife around until they get to area 1. Is that part of the question? Can't remember if that's part of the question, but just like, oh, I've missed the middle. Don't worry, I can just like rotate the knife. Is it going to cut to somewhere over on that side? Maybe I need to go a bit further this time because maybe the point XY was somewhere weird. Right, I do love the phrase sketch the region R of the cake. They're really good. The cake is a square, so you can draw the square, but you know, good times. And then this part is to sort of redo lots of the work to find some inequalities and sketch the region where these both hold, and it just works out to be quite similar work with quite similar curves at the end. So your reward for getting all the way through parts 1, 2, 3, and 4 is to then do something very similar in part 5. The thing I would like, of course, the thing that would make me smile if I saw your work for this question, maybe not in the exam, but if you were, let's say if you'd handed in work for this question because we were practicing maths in person and you'd handed in some work, the thing that would make me smile would be if you did this check down here. It doesn't say to check your answer, right? It doesn't say to check your answer, but I think it would make me smile if you did a version of that check later on. It would demonstrate to me, I think, as your tutor in this imagined scenario, that you knew that you were copying the steps of the previous bit of question, or that you just always check your work, right? Maybe you always check your solutions as you go along. So back in the day, I'm talking about working out like this because back in 2021, people did submit working out for these geometry questions and pictures of cake and all sorts. In 2025, the year that we're talking, I said that so strangely, I'm so sorry. In 2025, people aren't submitting rough work in the same way. The multiple choice questions are just multiple choice, and the long questions, people are typing explanations, written answers, essentially in boxes, not using complicated mathematical expressions. I mean, you have numbers and brackets and stuff, but so you're not going to be expected to draw a picture of a square. Good. People talking about vacuous truth. Oh, look at this. People have learned about vacuous truth. Very good. Okay, good job, Anonymous. Who also asks, or maybe it's a different anonymous person, what's my favourite place in Oxford? I am going to pick a New College thing. Let's see if that works. I'm going to pick the Mound in New College, which is this mysterious earthworks in the college. It's got these ancient walls and the college buildings, and then there's what would normally be a kind of flat lawn, except for mysterious reasons, it has an enormous mound of earthworks. It's covered in grass and trees, but it has this kind of artificial ancient hill in the middle of the college. So I'm going to pick that because you go. It's got steps. You go up the top, and then you are surrounded by trees and stuff. Despite being in the middle of just like a lawn of a college, which is kind of a fun experience. Right, let's see if that works. Much better. Thank you, Rosie. Yeah. Okay. Good. Okay. Right. I would say that I'm not sponsored by New College, but they do pay me. So they pay me for teaching. So maybe they pay me to do open days sometimes. It's that bad, right? Okay. Before I have to put #ad into the YouTube title, let's do another one. I haven't done the calculations down here. You could tell me off for that if you like. I didn't do the sketch either. I sort of think for the calculations and the sketch, you want to go and look at the solution on the website, right? But it's the structure here really is. It says find two necessary and sufficient inequalities because that is precisely what we did up here. It says both up here. You have to have both of these things being true. K has to be greater than 0 and less than 2. And hey, guess what? M has to be greater than 0 and less than 2. So it's trying to get you to redo. Because we had 2 over here, it's 2 again. Partly because it's a very similar calculation, but partly because, well, that's what's going on. If this was an interview question, it's not, but if it were an interview question, then of course the interviewers would be there to help along the way. We might encourage you to check your answer, of course. We do it bit by bit. And I think what I'd do around here is check you were happy doing the similar calculation without as much help the second time round. And then at the end, I might ask you something like, is there any overlap between those two regions? You've done a sketch in part 4 of the region where, deep breath, there is a value of k such that the point 0k joined to xy gives you a slice of area 1. And you've done a calculation in part 5 where, deep breath, there's a value of m such that the line to m, 2 gives you a slice of cake of area 1 on the left. For a fixed x and y, is that ever in both regions? Maybe the way I phrased that, maybe I shouldn't phrase it just like that, because with a grin and a question like that, you're probably primed to say no. But we'll see. Is it reflection in the line x equals y? Oh my goodness. I don't know. Notice that this line is, this vertical line here is kind of fixed. It's the same in both cases. So chat's talking about some sort of, oh, I double tapped the button there. Chat's talking about a transformation. Someone said reflection in y equals x. What would that do? The problem is Charlie's first cut is the same in both cases. So I kind of don't want to transform that. And the answer is different. So, I mean, which could be fun. It could be a transformation if the answer I got for the previous one. Yeah. Does anybody want to do my bonus part of question? Not really. There's no overlap because thinking about Charlie moving the knife around the cake again, either the line up to this corner was enough, there's now enough shaded area underneath, or it was too much. That's not part of the question, is it? No, I really thought it could have been. Okay. There are cases where even going out to that corner is not enough, in which case Charlie must go all the way around here. That happens if this point is weirdly up in this corner, because then if this point xy is up in this corner, then you can't have very much area going to anywhere around this edge. You just get a very thin slice of cake a weird shape, L-shaped bit of cake like that, you have to come down to somewhere over here. Are there any points where you need to go all the way around here? No, that's silly. No. There you go, fun. Different answers to explain questions, yeah, well, I mean, notice people are going to write the same thing. It is hard to know how to mark your own explanations, isn't it? Cool, what next? That's what I think. Long question, so I go here, here, click, click. This is good, we've got 20 minutes. I think that's enough to talk about another one. Oh, I should have looked at what came second in the poll. Chat, I'm a level with you, I've forgotten what came second in the poll. We do it again. Sorry chat, was it 7? I saw someone in chat say that 7 was really bad. So maybe I've got to look at 7. Oh, there is something stuck to my glasses, like a bit of fluff or something that is just in the corner of my eye. So I might deal with that really quickly. Oh, 7 is so long. Not a good day for... Oh, there we go. 2-star day. Would not recommend. You got to demonstrate it with an actual cake. I kind of want to make a Desmos thing. Oh, I shouldn't just say that, should I? I should make the Desmos thing, right? Desmos thing where you go round and it shows you the area, maybe with some number, or possibly you press a button and it goes whoop, and it finds how to split the cake in quarters from. This is what we're trying to do: is trying to split the cake in quarters from a starting point where you have to do straight cuts out to the edge to make up for the fact that you've missed the middle. I think that's what I want. Yeah, and you've done a vertical cut. So that would be it. It would be a Desmos thing. It would have bright colours for the 4 pieces, and as you move around that point in the middle, it would join these things to different corners. Depending on, it's going to think carefully about the cases, isn't it? So it's a tricky Desmos to draw. Desmos. But that'd be nice, wouldn't it? Because it's always possible. You just move around and you hit 1/4, 1/2, 3/4 at some point on your way pinwheeling round. Let's have that as another idea. Because we've seen several questions, haven't we? There's that circle question. I've got it. This is my second idea. If you like stars and bars as a recurring idea, my next idea is going to be a kind of pinwheeling thing. Because we've seen this idea come up a few times. There was that circle with a line through an off-center point where the line was rotating around. We've had the triangle where the line goes through the center and rotates around. We had that kind of like double, triple circle area thing where there was a point that moved around, and there's this cake question where there's a bit of line and then you imagine moving this point around the edge of the cake until you get to area 1/4. All of these involve something that's rotating around and smoothly changing. So at some point you say when it gets to exactly the right point. So this is got a smoothly changing function. And the abstraction here is, I think, the rotation effect. I think that's something people find hard. For me, that's like a function of angle. We've tried to have, there was a theta in this question. I tried to add in a theta into that question. You'll be pleased to see that I did not put a theta into this geometry question with the cake. And what even is that? Oh, that's the double circle thing. There was maybe an angle x in that question, right? And because it's a function of an angle, I think people find it harder to try and imagine what that function might be like. And in all of these cases, that function is an increasing function. It just goes up. You just get more and more area as it goes up. Oh, but that's not true in all of those cases, because in some of those cases I should have drawn a periodic function. I retract my statement. Right. Question 7 is getting so many votes. It's going really well. Right. On question 24. Ah, yeah. We did some live. We did some. Gosh, did I do 1 hour on 2024? I think I might have last year. Was it 2? I'm not going to look it up. I've got to find out how long these live streams are. I think 7 is doing well. Here we are then. Oof. Okay, right. Can I remember how 7 works? Let's find out. Let's stop the vote. Computer scientists, you've won a great victory today through democracy. You have voted for a computer science question for 15 minutes. Here we go. Okay. Exactly when each of its inputs is 1, I've skipped this, and the output of the function is the minimum value among its inputs. So if you see any zeros, then min will give you the answer 0. If they're all 1s, then min will then say, well, okay, fine, the minimum is now 1. But I was really looking for zeros because I'm the minimum function. Gosh, I'm so silly with these things, aren't I? But it helps me remember what they're doing. Max is a different function, and it outputs the value 1 when you have at least 1, 1. If you see 1, 1, max gets excited and returns the value 1 because, amazing, at least 1, 1, max says 1. Good, okay. And then flip just returns 1 minus, so 1 goes to 0 and 0 goes to 1. I only got zeros and 1s in this question. Okay. One such function is shown below. Oh my goodness. Describe in words when the function outputs 1 and when it outputs 0. Brilliant stuff. So you've got to unpack it. And I think I unpack these things from the outside inwards. So for example, min says, well, when is this 1? This is only 1 if both, it's got 2 inputs, look, this one and then this one. How many brackets do I circle? 2 brackets. If both inputs are 1. So then investigate. The first one is 1. You need at least 1. You need at least one of the xi to be 1. So that this first thing will be 1. So that max will be 1. And then what's this flip min? We want this to be 1, and because of the flip, we want the min to be 0, which means that we need at least one of these to be 0. So then the answer is that this function returns 1 if at least one of the x is 1 and at least one of the x is 0. In some mixed case, not all the same. Which involves, I think, piecing it together backwards. You could check cases by plugging in numbers like 0, 0, 0, 0, 0, 1. There's not that many inputs. There's only 8 possible inputs. So you could do a little table to say, here are the values of x1, x2, x3. There's not many possibilities, right? Then you could just check. Right? Binary is easy. It says, here we are. There's only 8 possibilities. I can just about fit them on the screen. There they are. So in each of those cases, you could then go and work out what's the value of f. And that's not fun to go and work out, right? Maybe after you've done a few, you spot what's going on, but if not, you get down to the end and then you've got your answer. They are deliberately not called and or not. Fair question. They're subtly different from and or and not. I think it's safer to give them these names. The question is whether people have an advantage. It's sort of hard to say, so people who have met and, but that's everyone, because you all know the word and. Just understanding the logic of what these things do, you understand that level of logic, I think. If you've done Boolean logic, then I don't really know what that means that you've done, but, well, good luck if it's majority functions like this. Okay, here we are. The function majority, which is going to come up quite a lot, takes k inputs and outputs 1 exactly when strictly greater than k over 2. There are k inputs. It starts from 1, goes to k. I'm just going to zoom to check. Yeah, it starts at 1. Sometimes starts at 0. This one starts at 1. There are k inputs. Strictly greater than k over 2 if its inputs are 1. Explain how you can combine elementary Boolean functions to obtain the following functions. So majority x1, x2, what's that supposed to be then? Strictly greater. Strictly. Sometimes I like to rewrite things. This is a particular value of k, look. So I like to rewrite things using that value of k. Strictly greater than one of its inputs are 1. And now it's kind of silly, right? Look, so k over 2, which was a bit of a weird thing. Strictly greater than one of its inputs are 1. Oh, that means both 1. So what's that? That's min, I think. Yeah, min waits until they're both 1. min is the minimizer. It's just min of x1, x2, using those elementary functions above. Majority of three things, we need strictly greater, this is going to look weird, isn't it? Strictly greater than 3/2 of its inputs are 1. Sorry, I've written this like it's a true fact about the statement, but actually I mean part of a sentence, right? Because this strictly comes in the middle of a sentence. Outputs 1 exactly when is the previous bit of the sentence, whatever. Okay, so that's 2 or 3. So then we've got a task. We could have min, or we also need to build something which detects when precisely 2 of them, or maybe more, but precisely 2. So the way I would build this, I think, I'm interested in cases where 2 of them are 1, and I think I would build lots of both 1. So I would do the 3 comparisons using probably min, because min does something when both of them are 1. So I think I would take min of x1, x2, min of x1, x3, min of x2, x3. I don't know what I'm doing with them yet, but I would take these building blocks and then think about what I've got. So the cases I'm interested in, one of those lights up. One of them is 1. If the first 2 are both 1, then the first one lights up. If they're different 2, then I get one of these lights up. So I think, do I want max of these? These are kind of my possible voting council things. And then, yeah, and I think it actually works in general, doesn't it? Do I want max of this? Yeah, I think I do. So I'm looking at the little voting councils, like how that majority might be formed, and checking with min that you've met that threshold on that combination of elements. I need 2 of them in this case, so I'm looking at pairs. And then if you've met one of those, then you're good. So that's enough. Yeah, something like that. Okay. Okay, and then things that can be combined only majority functions. Find any 4 other Boolean functions of 2 variables that can be represented by combining 1 or more majority functions with 3 inputs. Oh my goodness. So the tricky thing here is that the majority functions have 3 inputs. So you'll need to do something like, so here it's kind of hot wired to be 1 as the 3rd input. So we could check what happens if you put 0 in for that third input. We can try putting x1 in again. What's the 3rd input? And it says 1 or more majority functions, so we can start combining them together, but the majority functions have got 3 inputs, so I've got to do something like this, I think. At some point, I'm going to put in something. I've gone very vague there, sorry. I would explore this by trying out different majority function messes. So like what happens if I put x1, x1, x2 in it? But I've got to be careful because the question is asking me for 4 Boolean functions. It's not asking for 4 hot messes of majority functions. So I should check that the mess that I'm making is different each time. It's no good giving 4 different messes that are each the same Boolean function. When I say the same Boolean function, I mean given the same inputs, it ultimately gives the same outputs as some other Boolean function. There's not that many Boolean functions on 2-bit input variables, so I've got to be careful that I don't list the same Boolean function twice with 2 different disguises. Right. Okay. Yeah, so we could try functions that kind of ignore one of x1 and x2, so I might explore that as well. So like majority x1, x1, x1. This is like some sort of majority thing where you only listen to one of the values and you let it vote 3 times, like some sort of like x1 dictatorship. Actually, this one is an x1 dictatorship as well, where you let x1 vote twice. So then it just, if x1 is 1, then it wins the vote. If x1 is 0, then the vote doesn't pass. So both of these are the same. It doesn't matter what I write there. It's kind of third member of the vote. Doesn't matter. And in fact, if I write 0 or if I write 1 there, then it doesn't matter. They give me the same Boolean function, by which I mean just looking at the inputs x1, x2 and the ultimate output. If it's the same in every case, it's the same function. Yes. Could also discard both values and make the constant functions 1 and 0. Yeah, I like that. Okay. It's a bit silly. If we're allowed to put 1 in, then we're allowed to put 1 in 3 times, right? So this is the function that's always 0. This is the function that's always 1. We can do something else, can't we? We haven't tried majority x1, x2, 0 yet, which I feel like might be different again. Ooh, that's terrible handwriting. It's really gone off the rails. So if one of them is 1, that's not enough. You need both of them to be 1. I've met that before. That's min of x1, x2. And this one is max x1, x2. So have we got 4 now? Yeah, we've got the x1 dictatorship, which we've written in 2 different ways. We've got the 1 function, we've got the 0 function, and we've got min. That'll do. Right, question in chat. Before we move on. For the show that questions, e.g. show that x equals 3 as a root, can we just plug our value given in the question? Yeah, you can just do that. I think some exam boards for A-level are pretty strict on the idea that you have to derive something. So this is this question here. That you have to deduce it as if you don't know what you're trying to prove. As far as I can tell, that's not really a thing in mathematics. That if you're trying to prove a statement, you are allowed to know what it is. So as far as I can tell, it's not a real like math skill to prove something without knowing where you're going. So if you want to prove that p of 3 equals 0 given p of x is this, then the proof goes p of 3 is 9 minus 4 times 3 plus 3 equals 9 take away 12 plus 3 is 0. You don't have to go proof, well, suppose that we don't know what that number in the brackets is, well, then we could factorize the quadratic and we can find out that x is 3 or minus 1, but then we don't know which, but then you read, yeah, it's like, what are we doing? Just plug it in, that's fine. What are we up to? Oh, is there a good SMC question? I don't think I've got access to them yet, but Rosie says I'm going to enjoy the SMC floor functions question. Cool graphs. Nice. For the last part of the question, which I remember being hard, the key thing is part 4, really, I think. So we should do that one just to wrap up. And then I think I'm not going to say very much about the last part for time, sorry. So key thing here is if you build something out of majority functions only, then taking the inputs and increasing an input can only cause a majority function to switch from 0 to 1. It can't go the other way. So if I set up my function like this, if I do this, there's no combination of majority functions that will give these outputs. If it's giving 1, when you see these inputs, then no matter what kind of hodgepodge mess of majority functions nested inside each other with extra 0s and 1s going in there, increasing this x value up to 1 can only make the majority functions change from 0 to 1. Maybe they were already 1 in the kind of mess of this. Maybe some of them are more 1, maybe some more of them are now 1, but that cascades through the network of whatever you've built with nested functions. If some of them are now 1, well, maybe the outside ones that contain that, maybe it was already 1, or maybe it now is, but it can't go down to 0. If you were already winning the vote, then changing this to 1 doesn't make you lose the vote afterwards. Even if the vote leads to run on extra rounds and more voting later on that's enabled by winning previous votes. Well, we were winning already. This just makes things better. That's the intuition. Floor functions are super interesting. You've seen the questions without doing SMC. Oh, maybe I can get them. That's my evening sorted. That's a key property, and that comes back again in the last part. So that's not even loading. It's back in. There we go. Where we can use elementary functions as well. The answer to the very last part, as somebody said in chat, the answer to the very last part is no, because of a similar sort of confusion where you can have a case with in parity, where the parity function notices a change in some of these x variables, whereas the z's might not notice that change. In particular, if you have all of the inputs, all of the x's being 0, and you just change one of them, then parity will notice that change, but the z variables won't notice that change. Oh, there they go. There's the question. The z's take the minimum of pairs of x's. So if you're just allowed to use inputs z, then you lose information. You can't spot that difference between 4 zeros and 3 zeros and a 1. So kind of like the majority functions always increase, the z's tend to give you 0 more often than you might like. I found that after messing around with lots of kind of what can you do with z's. Right, can you build these things? Good, okay. We're going to stop there for time, I think. You haven't seen it, but it sounds interesting. Okay, floor functions on there is super. Just the concept is interesting. Good, I agree. Right, floor functions. Can we put that on the list of like stuff that seems to come up sometimes? Floor functions, where you round down. There's only one floor function, singular. Sorry, but there's lots of things you can do with it. We've seen 2 to the floor of x. We've seen floor of 2 to the x. I think. Maybe we've seen both of those. It seems to come up quite a few times on my questions. Right, good. Do I have tips for getting out of a burnout stage? Have some sleep. Take some time away. Try and remember why you actually liked doing this in the first place. Sorry that it's happening to you. Everyone I know has been there at some point. Ceiling function as well for tomorrow. There you go. I hope you feel better soon. Right, okay. Take it easy, everyone. Have a good evening. Have a good weekend. If you're doing TMUA next week, then I hope it goes well. I'll see you next week for another MAT live stream where we've got just a few more past papers to look at. If you're getting bored of past papers, feel free to go and do something else with your time. It's your life. But I'll be back on Thursday at 5 o'clock. I'll see you in 166 hours for another episode of the Oxford Online MAT. Oh, once again, Oxford MAT Livestream. There we go. Right, take care, everyone. See you around.